video in our series involving Capture, Vectorworks, Lightright, and Nomad software. And today, what we'll be working on is our Capture imported file. We've already dragged and dropped and replaced our fixtures with actual Capture fixtures. And today we'll be patching. Now, importing a Lightright file into Capture requires you to export the file as comma separated values, then mess with it in Notepad and get it to agree with what it needs to be. Then you need to go through the import process just like importing data. And you open this up and you identify your fixtures by some common value. So this would be cool if you could do anything useful and helpful with it. This import will not bring in color information. It will not bring in gobo information. Right? I can have these properties. That's all I get to import. There's no color, there's no gobo information you can bring in. And you've already got to essentially patch them in one form or another before you do this yourself. So you're spending $2,000 on a program that can't import a Lightright file. Let's not get upset about that. Let's do what we have to do here in Capture to get our units patched. So it's actually pretty nifty. We can select these all and give them things like channel numbers and addresses. So let's start with addresses. We're just going to go one-to-one. Left to right. So we've selected all our conventionals. We're going to hit the little wrench. Sequential circuits. Well, sequential patch is what we really need. Start address 8.1. No channels between fixtures. And what this will do is pick every fixture in the left to right, up and down order, the same order we selected them. And if you select them in reverse order, it'll populate them in reverse order, with the exception of selection boxes, which will always go left, right, bottom, top. And we'll patch these fixtures. Okay, so they've got patch. We've got a circuit number, which is not important unless we wanted to export what we've just done. And so this patch is important for our ArtNet control. Here's our MAC 250s. They're going to start at address 14 and jump up with their DMX addresses. Great. We're patched, and we've given these guys their channel numbers. So we've just gone 1. I really like to change these channel numbers. This guy will be 1. That'll be 2. That'll be 3. And we can go on down if we wanted to, but we could just select our cool fixtures and we can sequential channel. Let's say they start at 10. Click assign, and you'll see sequential channels in there. Do the same for our other set of fixtures, which will start at 20. sign. All we got left of the Sykes. Start those at 30. Okay, move over to our library. Let's put some filters in here. So we're working with Roscoe and all of our cools. Were double check. One of our cools are 362 and 114, so we can actually just search our 362. And wait. 362. Drag. Drop on all the select ones. If we were to drag and drop on the electric, we would change the electric's color to R362, which we don't really need right now. Same with these guys. And those are O2. Good old R02. And we have 114 in them as well. There we are, 114. So we'll select our fixtures. Drag and drop 114. These guys had 79. So how many of these fixtures has got their selected items? Its color frames include 362 and 114. These guys had 132, if that's correct. 132 and R74. So you can always import gobos as well if you'd like. The gobo will always be fully focused. So now we've colored up our instruments. Now, the patch file that we export from Capture Argo, is not going to be compatible with our Nomad software. So we've got to get the LightWrite file, import that, that's where LightWrite comes in. And then we have the luxury of using our LightWrite file to automatically patch the Nomad. So as long as everything's the same that we started with, Let's head on to light right. Export. Let's get tabs separated. Great. I will quit light right. So here we are ready and prepared to launch ETC Nomad. But there are some settings we need to change first, and when we do launch, we will use offline with Visualizer. But before we do that, we have to set up a network, don't we? We need to have data coming out of the Nomad somehow and into Capture. For that, we're going to be using ArtNet, but we're on the same computer. How are we going to sit one computer next to another and plug a little Ethernet cable in between the two? Or we're going to have an Ethernet cable that plugs in on our computer and then loops around and plugs back in. That's a little silly. But Microsoft has a debugging tool called Loopback Adapter. So we've just got to install and enable this debugging or remove our piece of fake hardware is Device Manager. Great. So we're going to head on down to network adapters. You can see I've already installed one here. So we're going to go to Add Legacy Hardware. Select it from the list. It is a network adapter. We're going to wait. Manufacturers Microsoft. And we're looking for Microsoft KM Test Loopback Adapter. So you'll just click Next and install that. So I've installed the second one here. I'm going to quickly remove it. Great. So the loopback adapter is a network that you can connect to in your network settings, and you should be by default connected to it. Gotta watch out. Sometimes you will drop like a wireless connection and stay only connected to that. But that can be a just an accidental setting. Right. So we know we're connected to our loopback adapter. It'll be labeled Ethernet, Ethernet 2, something like that. So, settings in the Nomad. It's a network. You should be able to see Ethernet 2 online. It should already have its own IP address. We're good there. We need to go to Output Protocols. By default, ArtNet will be disabled. Enable ArtNet. Across here, we want it on Directed Broadcast because it's only going to that IP address. We could send it out over everything we wanted if we had the desire to do that. And the ArtNet start address is a universe offset. So you could have your universe set up for universe 3 or universe 0. Universe 0 means ETC universe 1 is ArtNet universe 1, ArtNet universe 1 is ETC universe 2, and along we go. If I change this to 1, my universe 1 comes out as ArtNet universe 1, and so we put on an offset. So you could use this to kind of network consoles together and keep them from accidentally interfering with each other. We don't need to do that. ArtNet starts 0. So want to make sure our multi-console interface protocols are on. That will come in handy later. The rest of this is good to go. And hey, here's where you might want to set up, say, a networked remote focus unit or something like that, if that's your fanciness. Great, we accept our network settings. We open up offline with Visualizer. It'll warn you. You will get random DMX pops going across the network. And if you try to use it live, it's going to look really weird. In the Visualizer, it'll still look weird, but it's survivable because you don't care about the random pops of DMX. We've imported and patched our file, just like you would any shell. Import light right. Let's open that up. Everything we need. We can map our devices in here. And then once you've finished your import, you should see something like this. Let's flex it real quick. Great. So we can capture. We need to set up our universes. So as you're starting out here, it should already be listening. If you don't see anything, you can take a look here, and you'll start seeing, oh, some things are at different percentages. Nice, we're in business. But that's the universe you want to connect to. Universe 0, subnet 0, input 1. Good shape here. Our next step is going to be to pick a nice view we want to look at. So let's look at down this wrench here, live view from perspective. So we've got some lights on already. And you can see things seem to be working. Let's go to Q out. And let's put the board into highlight mode. The one will be at its highlight value. It's our next key. Here we are on channel 10, so we're using page up, page down is our next and last. And since we're in highlight mode, we can easily jump between our next channels. So that means I can stick ears off to the side over here. This small little go. I can make capture. This big as it'll go. I can start focusing out these LEDs. So, clearly I've got a patch issue. That channel 10. Okay. So select your light, click, and drag to focus. Right click and drag. You can see things hang up and create problems. So perspective view does not make this easy. We still want to be able to tab over to our ES console and hit the next one. So let's get a nice front view. Go there. Next. Right click. Next. Right. So backspace, we'll drop out of highlight mode. And now we're focused up. What we're going to do is something special with these movers here. Let's see them from the front. We can transform, rotate 90, place them on the plate. And we can transform, rotate 90. Yeah, no, let's rotate you more than that. So they look the way they really would. And we got to remember when doing this, you see the option to invert pan and tilt. Let's not do that here. Let's do that on the board. Okay. So here we see our margins 1 and 2 are the ones that need their pan and tilt inverted or swapped. There we go. Swap pan and tilt. And that guy. Swap pan and tilt. And this guy doesn't have its pan and tilt swapped because it's pointing straight down. It's not going to give us any trouble. Okay, I'll get back to us in a second. Here we are. Here we are with our EOS family Nomad in the top right corner. And I've got some cues I'm going to run for you. That was the DMX flash you just saw there. Right. Now we finished our cues. Let's try those moving lights. And what you'll notice is we can actually control values live in our visualizer. So I can say you can have a fan, you can spin, and you can put something else in there on the fan. We can have a rotation with a prism and a gobo. And we can bring you guys down. You can pan a tilt on there. Be on our man. Be on our wall. Gives a cool wall effect. 93. Can also be up on our wall. And so that is the steps required to get a functioning visualization program together for everything we need to do. And it allows us to pre-visualize all our cues. Ain't it indeed? So tune in for some more videos. We're going to explore maybe a different program or two and see what we can do about getting some light rating ports in. All right, thank you very much. I'm Lewis. Like, share, subscribe, and I'll see you around.